Nearly every science fiction writer or reader has had the fantasy about living on a terraformed alien world. Unfortunately, that next leg of astronomical pioneering, the semi-final frontier, colonizing our own star system, may prove far more problematic than we first imagined. It doesn't take much more than a quick Google of Mars or Venus to learn how inhospitable their surfaces are. However, there's an even greater hurdle to overcome. How do we establish biomes upon a planet with far less protection from the solar wind than our home Earth? While there is evidence of water on the surface of Mars, we only have unconfirmed suspicions of life on the surface. While the presence of water on the surface of Mars makes it tempting and proves it has potential as a candidate, terraforming the planet will take many steps, and each one could be hindered by multiple factors. With Mars virtually naked to cosmic radiation, we have a big job ahead of us. I'm Eric Malachite, author of Echoes of Olympus Mons, and this is Science Get. While most of the planets in the solar system have an atmosphere affording them a level of protection against the cosmic background radiation and solar wind, Venus boasts the most powerful force field against solar and cosmic radiation. Its thick atmosphere and its unique composition absorbs and reflects most radiation away from the surface. Some of the substances in the Venusian atmosphere remain mysterious and unidentified. This reflectivity actually helps to make it a good candidate for colonization, though access to the surface and surviving on it is hazardous. But you should check out our Cloud City video as soon as you're done with this one. It will blow your mind. Clouds of sulfuric acid and carbon dioxide drift across its surface. This and other reasons make it unpopular, though most of our viewers would probably prefer to look further from the sun to spread humanity. However, looking at the most exciting candidate in the solar system, I put that in quotes, Mars, radiation becomes a serious concern. Mars is blasted on a daily basis with cosmic and solar radiation that makes the surface of the planet a difficult place to establish a biosphere, the ultimate goal of terraforming. It is well documented that most forms of life don't thrive in irradiated environments very well at all. This web of life on our planet Earth is complex and interconnected, and even Homo sapiens have bacteria that we use to process nutrients. The lack of these bacteria can cause such problems as lactose and soy intolerance, both forms of protein that our body does not natively process. So at some point, some of us formed a symbiotic relationship with bacteria that gave us the ability to process these sources of dense energy. Now, taking this information, we can apply similar logic to plant life. To gain access to the nutrients they need in order to thrive, sometimes symbiotic relationships are formed between bacteria and fungi. We don't see most of them, but these are the foundation of life on our planet. And at this size, the dangers of environmental hazards change. While there are cases of extremophiles which can survive in highly irradiated areas, here on Earth there are a few cases of highly irradiated locations where the ecosystem is in a precarious state. In the Chernobyl exclusion zone, the pine trees exposed to the fallout turned red and died. Shortly after they were bulldozed and buried under some sand, would you be surprised to find out that those trees still remain virtually undecaying to this day? What biologist Timothy Massow of the University of South Carolina, Columbia, and his research discovered was that within the exclusion zone where the radiation was most concentrated, the forest debris that littered the ground had barely decayed at all since the Chernobyl meltdown. In a year-long study performed within the exclusion zone, he placed bags of foliage within the irradiated areas and other unirradiated areas as a control. With the control group, they found that within a year, the leaves and pine needles they set out were 90% gone. But within the highly irradiated regions around the Chernobyl nuclear plant, 60% of the plant matter remained. Other parts of their methodology in the experiments allowed them to discern whether the decay was due to bacteria and fungi or insects. In Chernobyl, complex life was still managing to eke out a niche. However, the fungi and bacteria were failing to do their part as decomposers. This makes a lot of sense though. Multicellular life shows redundancy, protective measures, and adaptations that allow them to cope with more complicated and dangerous situations. Macroscopic life absorbs and retains radiation, typically until it reaches a fatal point. In fact, within the very reactor of the nuclear power plant in Chernobyl, a black fungus grows on the walls. This fungus is capable of radiosynthesis, a process where the fungus produces energy by metabolizing radiation. This melanin-rich fungus, dubbed Cryptococcus neoformans, is very dangerous. Exposure to it causes serious respiratory problems. Not a great candidate for human habitats. Thankfully, there are other candidates such as Cladosporium sphaerospermum, which as recently as 2019 was involved in an experiment to determine if it was viable as a means to protect against radiation, in preparation for the possible trip to Mars. Looking back to Mars with terraforming in mind, we already have some trace evidence that there might be bacterial and potentially fungal life beneath the surface of Mars, so there might already be life present that could deal with the rigors of Martian soil. However, terraforming is attempting to create an Earth-like environment on an alien world. This means that we'll need to introduce plants and eventually animals. However, that first hurdle could be massive. We have the case of tardigrades, some species which can survive in highly irradiated and oxygen-deprived environments. Cladosporium sphaerospermum, a form of fungus discovered in 1886, is one such form of fungus. These black fungi are another form of extremophile that may prove useful. Unfortunately, these fungi aren't very useful in terraforming. For terraforming, we need fungi and bacteria that can break down waste in whatever form, whether it's our own biological waste or the decomposition of dead life. Other studies have shown that life within the exclusion zone is stunted, in part due to the adverse effect radiation has, but likely also due to the decomposition cycle that usually occurs being halted at the microscopic level. Worst of all, this build of plant matter is also a fire hazard. It may come as a surprise, but the fire and smoke that it could produce would spread that contamination. Earthly troubles aside, it's not as if we're helpless. Human beings have been adapting species through selective breeding for centuries. Sea monkeys, for instance, were a form of brine shrimp selectively bred to survive only within the patented solution peddled by their makers. That said, it's possible that we could produce an extremophile to prime the soil for the first Martian trees. We have a few fungi we could use as a starting point. With time and trial, we could adapt and learn what unique environmental hazards are present on the surface of Mars. Maybe with patience, we'll be able to tailor a terraforming strategy to make Mars habitable. It's still a monumental task, one that I think will require quite a bit of trial and error in order to perfect. However, we do have hope, since Cryptococcus neoformans has even been hypothesized to be able to grow on the outside of spacecrafts. They'll be a bit daunting at first, but given these fungi seem to be capable of blocking or metabolizing huge portions of the radiation that could harm humankind, what if the future of space travel wasn't an energy force field or a magnetic field around a ship, but a microbial one? Not to give credit to a certain sci-fi show in their creative use of mycelium. Finally, it's the speculation of Saiget that a phase of terraforming anywhere is going to include introducing large cultures of fungal spores to the Martian planet and allowing them to take hold. So if Mars has even a small chance of becoming habitable for human life, we will have to experiment to see what kind of life will take hold there, and how it could be affected by the bacteria and fungi already present. Unfortunately, we can't yet get samples of these bacteria to Earth in order to experiment with introducing them to prospective terraforming flora. Until then, we can speculate and study all the data coming in and prepare. If you enjoyed this content, be sure to leave a like and let me know what you think our chances are of terraforming Mars' surface. And be sure to smash that subscribe button and ring that bell to never miss a Science Get video. I'm Eric Malachite, and I'll see you next time.